Welcome to Flip Lesson 77, where today we're going to look at lines, angles, and planes. This is part one of the video, as there are many concepts we want to review here today. So we start with the idea of space. When it comes to space, we're not talking about outer space, though outer space is definitely included in this idea, but space in the idea of understanding how space works, understanding how things take up space, different types of objects, different types of ideas, how our vision can see spaces, and how we represent those things through different geometric ideas. Now, when we get to these different types of spaces, we can start talking about dimensions. First dimension, second dimension, third dimension, 3D, right? 3D, third dimension. And so we have these different ideas. And from here, we can move into different kinds of dimensions. And as we look at different kinds of dimensions, we get our understanding of how we visually see things on paper and in the world. And that's where we get these different terms, right? We have this wonderful dot here, which we call a point. And a point really doesn't have a dimension. It doesn't really fit on any plane. It can be anywhere, everywhere at the same time. So it's not really in a dimension. Right, as we look at a line, we understand a line, and once you put a line on a page or on a piece of paper or even on a whiteboard, suddenly there's something is there. We can see it, we can view it, we can manipulate it, we can do things with it. And our eyes can understand it in the sense that it has distance, it has shape. And lines allow us to do that. When we move to planes, right, that's when we start getting into 3D ideas, right? And something, even with a drawing, something can become three-dimensional, and we start to see different types of angles, different types of routes, and we get those different ideas. And so we have space is really the big concept that we look at when we look at most forms of geometry, right? And if you have some more questions on how space really works, don't be afraid to ask. Let's talk about these concepts that we've looked at in the past and see how we're going to use them today. So we start with the idea of a point. Point, of course, we've covered already, right? We got the simple point. We call it point A, right? And just like that, you know what a point is, right? From here, we move on to a line. A line, of course, is signified by the fact that a line can go on forever, right? And we name a line in one of two ways. We can call it line AB, and you can see the symbol there for line above the A and the B, or lines can also be named the opposite way. The order doesn't actually matter, especially on this problem here. Sometimes, depending on what the question is asking, order may have some significance. All right, with array though, order is pretty important, right? And we look at array, we can see one endpoint here, and then of course the line going on forever. And so we're going to name that ray RQ. You see the symbol for ray there. And it's always important, though, to remember that rays have to be named starting from the endpoint and then going to the direction of the ray. So if I were to call this, right, TZ, I would actually have to name this ray ZT because, right, here's my endpoint, here's my ray. Even though this symbol looks opposite what you're seeing on the screen. Finally, we get our last idea, which is a segment, and of course segments are named like this. And very similar to lines, other than the fact that, of course, segments end. We have two endpoints, and so we have that different idea. From here, we can use these concepts to go further, right? If I look at this line segment, JLB, suddenly I am able to use this to understand measuring things. And I could take out a ruler and start to measure things, but that's a different lesson, right? Today you're just going to be given the measurements. But we can really write this or talk about this in a couple different ways. We could write M, standing for the measure of JL plus the measure of LB is equal to the measure of JB, right? Sometimes it's written in a much simpler way, right, without that M there, but we do want to recognize this M means the measure of. Right, that's why that symbol is there for us to remember and realize that that means the measure of. But sometimes, like I said, it's written just JL is plus LB equals JB. And so from here you can and would be able to solve different kinds of problems based on that. And if I were to give you a number like this is 5 and this is 7, right, you would be able to figure out that this is 12. Right? So we have that concept there. All right, so using that information then that you were just given, go ahead and use this line to solve these problems. Go ahead and pause the video and answer these sample questions. Name the line, 2 rays, and a segment. From here we move on to our other concepts that come with lines. Lines have specific directions that they go, right? Vertical, horizontal, and so we have vertical lines, right? That's up and down, horizontal, left, right. And when lines interact with each other, we have different ideas coming out also, right? So the first one we see here is the idea of this symbol right here. Right, now this symbol might look new to you, but this is a symbol that we want to get familiar with. Right, this symbol means perpendicular. And so the question is AB perpendicular to CD? All right. And so I can write it like that, and I can say it like that. And so the question is it yes or no? And so as we look here, we're going to look at the intersection here and say, is that a perpendicular? Is that a right angle here? Right? And we'd say, yeah, that's a right angle. Those are perpendicular lines. And so the answer would be, of course, yes. Nice work. Nice work. Right? From here, we can pull in our second concept then, which is, once again, another symbol. Right? Can you guess what this symbol means? Right? Right, we always study these two together. What does that one mean? All right, okay, I'll give it to you. It's parallel. Maybe you figured that out. Maybe you said it out loud. Maybe everyone in the library or in your classroom is looking at you a little bit funny. Or maybe mom and dad are like, oh man, you are talking to a computer right now. That's a little strange, but hey, you're learning math, so that's good. The question is, are they parallel with each other? Parallel, of course, the symbol really represents what it needs to be doing. They're running into each other. They're never going to intersect. So is that statement true for AB and CD? The answer, of course, would be no. Right? If I wanted this to work the way it was, I would have to get CD to run straight across like that so that they would never intersect. So we have those two concepts also. All right, we're going to pause the video there, and you can come back and watch part 2. Or stop the video, not pause it.